Okay, let's talk about displaying multiple waveforms. We often want to look at multiple places on our circuit. For example, we might want to look at the input of a circuit and the output. The first thing is we need to get a stable display. The easiest way to do that with these scopes is to press the AutoSet button. The AutoSet button will figure out what's going into the scope and give us a basic display. In general, this display is not what we actually want. But in this case, we can see that we've got two channels. We've got channel 1, channel 2. We're at 100 microseconds per division, so channel 1 seems to be some sort of square wave. Channel 2 is some sort of repetitive wave. And what we actually have here is channel 2 is the output of a low-pass filter. We also looked at this in the time domain, which is a resistor and a capacitor. The problem is this is not a very good way to look at two signals that are related. That's true here, particularly where one is the input of a signal and one is the output of the circuit. It's much better to look at this kind of signal overlaid so that we can see what the output is with compared to the input. So what we're going to use is you can use the vertical position control to overlay the 0 points. So I've overlaid 1 and 2 here. I'm going to use as much of my screen as I can. I don't think I can go much bigger. Arguable. Let's just turn down the amplitude of our input so that we're not off screen. And there's no need to look at multiple versions of the same thing. So what I'm going to do is I'm going to look at a single period of the input signal from where signal 1 goes high to signal 1 goes high. And now by overlaying them, I can see exactly what's happening. So if two signals are related, having them overlaid rather than one above another is a much better way of looking at them. What we can see is that our input changes immediately, but it takes a while for our output to follow, and our output follows exponentially as we'd expect based on what we know about resistors and capacitors. So when you're showing multiple channels, you can show up to 4 channels. Where you set the ground, which is to say the 0 point, is very dependent upon what the circuit's doing. If they're not related, then it makes sense to stack them. But if one is the output of the other, it makes sense to overlay them. For example, we could be looking at sine waves. And now instead of looking at the time domain response, we're looking at a single frequency, which shows us the frequency response of a filter. And we know that the filter will attenuate above f sub c and also cause a phase shift. And in this case, we actually are pretty close to f sub c. The frequency is, well, we're below f sub c. Let's go to 10 kilohertz, which is f sub c for this filter. And so if we measure, what we should see is, and also we'll go up to an amplitude that's big enough. So our amplitude is now 10 volts peak to peak on our input. Our output's 7.12 volts. It should be about 707 at f sub c, and we should have a 45-degree phase shift. By overlaying them, it's much easier to see the phase shift. Had we used AutoSet, and here's what AutoSet will show us. Well, first of all, AutoSet doesn't have the same vertical scale for both waveforms, so we can't really tell that this is attenuated from this. We certainly can't tell that there's a phase shift. There may be, but unless we overlay the two by moving their 0 position to the same place and setting their vertical sensitivity to the same value, it's much more difficult to tell. And we want to zoom in. Once again, we don't care what's going on with 5 of the same thing. And now we can see that there's a phase shift. And if we measure that phase shift, I don't know that we're going to be able to get quite a full cycle. Well, it's pretty close to a full cycle. So this is 10 microseconds per division, 10 divisions, 100 microseconds, because we have a 10 kilohertz input. And we'll notice that we've got 1 and about 1/2 division, which is 15 microseconds of phase shift. 15 microseconds is 45 degrees, 90 degrees, 180 degrees, and then 360 degrees. So we have just about 45 degrees of phase shift. That would be almost impossible to determine if we were in the stacked mode. So make sure you use the correct mode when you have multiple traces that you're looking at.